Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Ah, Okay, so we have question 2 on vectors in 2D. And then we are told consider the three forces acting on an object as shown in the diagram below. So we have the forces on this object are the force here applied of 150 Newton. And then we have the tension of 250 Newton acted at an angle of 45 degrees above the horizontal. This one is acted at an angle of 20 degrees above the horizontal. Then we have the gravitational force here, or the weight on the object, which is 100 Newton, right? 2.1 is saying define the term resultant of a vector or resultant vector. So we're just gonna quickly run to that and say this is a single vector having the same effect as two or more vectors acting together, right? So this was just supposed to be a single vector having the same effect as two or more vectors acting together, right? And then that's how you define it exactly as it is right there. Then, okay, we have 2.2. It's saying determine the magnitude and direction of the resultant horizontal and vertical forces. Okay, now for 2.2, we are going to say, let's start by resolving these forces that are being acted at an angle. So we know according to our vectors in 2D, whenever we see a force that is being applied diagonally and then it has an angle here, we know that we must always resolve that angle. We resolve it into components fx and fy, the horizontal component and the vertical component. But then also another thing that you should be mindful of, you should check if your angle is given in the right position. You should always make sure that your angle is between this horizontal line, the x-axis, and the force in question, and the diagonal force. If the angle is given here, for example, then you need to first subtract it from 90 degrees. So if you were given, let's say, for example, 70 degrees here, we wouldn't use this 70 degrees. We would have to say 90 minus 70 degrees, and then in turn, we use the angle that will be produced here. So always make sure, put it in the back of your mind, the first thing that you have to check whether the angles are in the correct position. Your angle should always be between the horizontal and the forced question. The horizontal and the forced question. If it's here, subtract from 90 degrees. Okay, now let's continue. With this question here that we are given, we can see that the angles are just in the right position. So we can start by resolving the components for the tension here. So the tension will produce the vertical component and also the horizontal component. We will name the horizontal component Tx and the vertical component Ty. Now we can calculate Tx. Tx is T cos theta. And then what is our tension? 250. And then cos 45 degrees. Then when you punch that into your calculator, you will get 176.78 newtons. And then to which direction? As we can see, our Tx is going to the right. And at this point, we can now calculate Ty. For Ty, we are going to say T sine theta. And then our tension again is 250. And then sine 45 degrees. When you punch that into your calculator, we know that cos 45 and sine 45, they are equal. So that means I must also have the same value there, 176.78 Newton. But then to which direction? This one is going upwards. And then, okay, we have calculated the components of the tension force there. Now let's go to the force applied. If we have to go to the force applied, let's resolve once more. So the force applied will have components Ty in that direction, and then we'll have Tx or Fx in that direction. So remember, it's now the force. So this will be Fx, and then that one will be Fy. Now let's calculate for Fx. We're going to have F cos theta, and then our force is 150 cos 20 degrees. If you punch that into your calculator, you get what? 140.95 newtons. And then to which direction? To the right, to the left. Note, it's to the left. So it's going that direction. So this is left. And then what about Fy? This will be F sine theta, and then will be equals to 150 again, but then sine 20 degrees. If you punch that into your calculator, you get what? You get 51.30 Newton. And then where is it going? Upwards as well. So as you can see here, I tried to indicate it shorter than the ty here because with the angle and the force that I'm given, I just saw that it will be smaller than the ty, right? So, okay. Then once you have this, remember you must calculate the resultant of the horizontal and the vertical forces. So to calculate the resultant, if you say resultant of the horizontal forces, then this is simply going to be, now when it comes to this, you must make sure that you have chosen the direction. So you say you take right as positive, then automatically it means that whatever that's going to the left will be negative. So left as negative. Then that means I will have 176.78 plus negative, because it's going to the left, 140.95. This is the resultant. Remember, if your forces are in opposite directions, they will subtract, right? And then when you do that, this is going to give us 35.83 newtons. But because it came out as a positive, the direction will be to the right, because obviously we know that it will take the direction of the bigger force. So the bigger force in this case is your Tx, and then it was going to the right. Therefore, the resultant will also go to the right. Now, let's calculate Ry. With Ry, we must not forget that we also have this one here acting in the opposite direction, which is your weight. So what we are supposed to do is add these ones up because they're all going in the same direction upward. But then we must then subtract this because this also forms part of the vertical forces. And then this is what we do. So do not forget that one. So this is what we do. We are going to have 176.78 and then plus 51.30, but then remember the 100 here plus negative 100. Why negative? Because it's acting downward, and then we chose up as positive, so that means down as negative. So now our resultant of the vertical forces, if you punch all that into your calculator, you will get 128.08 newtons. And then where is it going? Upward. Obviously upward because these two here, when they add up, obviously the vertical forces to the upward direction will be much greater than the vertical force to the downward direction. Okay, and that's how you were supposed to calculate this question. So I've made you note these things. Whenever you have a diagonal force, make sure that you resolve into components, the horizontal component and the vertical component. And another important thing to note is your angles. Make sure that your angles are between the horizontal and the force in question. If the force is here, then you need to subtract it from 90 degrees. So make sure that you put that in the back of your mind. Okay, now we have 2.3. It says determine the magnitude and direction of the resultant force acting on the object. Note that what we have here are only the magnitude and direction of the resultant of the horizontal and the resultant of the vertical. Now we want the magnitude and direction of the resultant force, right? So the resultant force. So this is what we do. From the previous question, we found that the resultant of the horizontal was to the right. So we will say this was it. And then it was going where? To the right. So this was what? 35.83 newtons, and then to the right. And then we also had this one here, which was going upward So, okay, allow me to just draw it below here. So this is it. And then we also had another one going upward there. So I will use the parallelogram method for this one. So this is 35.83 newtons. And then this is 128.08 newtons. It was going upward. Now the parallelogram method simply means that if I want my resultant, I have to just put it like this there. So this is what I will do. I will simply close in here to form a rectangle or a parallelogram. And then for my resultant, this is what I do. I just simply insert it here like that. There we go. Now, to calculate the resultant, we do understand that if this is a parallelogram, these are both parallel and equal. Parallel and equal. Parallel and equal. Right? So that means from here, I can produce a right angle triangle here by simply taking this one and writing it over here, 128.08 Newton. Now we can all see that I have a right angle triangle at this point, meaning I can now calculate the resultant force. Right. So to calculate the resultant force in a two-dimension question like this, you always have to apply Pythagoras theorem. Then this is F res square will be equals to fx square plus fy square. Now the fx is the resultant of the horizontal there. So that's 35.83. And then square that plus the fy, that's 128.08 square, right? And then obviously when you want this, you have to then put it all inside the brackets so that now you are left with the resultant force. When you punch all that into your calculator there, this is supposed to give you 133 newtons. Right, so 133 newtons. But then remember, we also want the direction. So, but then the direction at this point, you cannot say right, left, or upward, or downward. Now you have to find your direction in terms of the bearing or the angle. Now let's talk about that. Let's clarify that. If you put your angle here, let's say this is your theta. What you are finding here, remember, this is now your north. So the direction that you are always calculating from the true north all the way to this part here, the resultant, is called the bearing. So if you put your angle here, that means you are calculating the bearing. So I don't know, there are different methods which different teachers at your school. Others, they make you calculate the bearing. Other teachers, they prefer that you calculate the angle from the horizontal. Now it's different. If you calculate it from the horizontal, let's say this is your beta. So that means you'll be focused on this angle here. If this is the one you are calculating, then it is called the bearing. So either way, whatever angle that you're going to find here or here, they are both correct. So if you sometimes see the memo providing two options for that, it's because for this one, for the ones that are calculating the bearing, and this one are for the ones that are calculating from the positive x-axis all the way from the horizontal line here. Both these directions are correct. You just have to find out what is comfortable with your teacher and what they're teaching you in class, and then do that. Right. So I will show both methods in this video for the sake of clarification. So let's say now we want our angle in terms of the bearing. So in both of these methods, you still have to calculate your angle using the trig ratio tan. So if we are saying we want the bearing, then the bearing always, it is calculated from the true north. Right. So always the bearing is calculated from here, the y-axis, all the way to the resultant. And then this is going to be tan theta. Because of that, understand that tan according to SOHCAHTOA, is opposite over adjacent. Now, if you put your angle here, you do understand that your opposite is now this side here, right? So I know a lot of you are being told that tan is actually y over x. Now that is questionable because when it comes to this, you have to understand that when you are calculating the bearing, now this changes to x over y. Right, because now your opposite side is now this side here. So it is best if you just know that tan theta is opposite over adjacent instead of memorizing that it's y over x or x over y. In this case, if we are calculating your bearing, your opposite side is now here and then your adjacent side is now this one. So the opposite side is the 35.83 and then the adjacent side is now the 128.08. And then calculating your theta, you'll say arctan and then 35.83 35.83 over 128.08. And then now your theta becomes what? If you calculate using the bearing, then your theta is supposed to be 15.63 degrees, rounded off to 2 decimal places. Right, that's for the bearing. That's for those who are calculating the bearing. For the ones that have been taught at their schools to calculate from the x-axis there, from the horizontal, then this is how they're going to have it. This is the ones that are being taught that it is tan is y over x. Because basically if you put your angle here, your opposite side is the y. And then your adjacent side is the x. So now you'll say tan theta is equals to 128.08 over 35.83. And then you say theta is equals to arctan and then 128.08 over 35.83. And then now when you calculate your theta here with this one, you are going to get 74. Let me quickly do it in my calculator. Then this is, okay, 128.08 divided by 35.83. So if I round off to 2 decimal places, that's 74.37 degrees, yes. Okay, so both these angles here are correct. That's what you need to note. And then if you can add those angles up here, you will see that they will add up to 90 degrees because over here the angles are complementary, right? So it's just a matter of, are you calculating the bearing or are you calculating from the horizontal? Right, if you are calculating from the horizontal, this is the angle that you are going to find. If you are calculating the bearing, this is the angle that you are going to find. Now, for someone who's calculating the bearing, their conclusion will be F res is equals to 133 Newton at a bearing of 15.63 degrees. That's the conclusion for the one who used this one. Now, what's the conclusion for the one who used that? F res is equals to 133 Newton above the at an angle at 74.37 degrees above the horizontal. Above the horizontal. Or you can indicate from the positive x-axis. Others would say from the positive x-axis, or you can just say above the horizontal, right? So both these angles are correct. That's what I wanted to clarify here. Both these angles are correct. It's just the point of reference that is not the same. Okay, so I hope I made my point clear with that one. So make sure that it does not confuse you anymore. Okay, then let's go to 2.4. 2.4 was only for 2 marks. So they're saying give the magnitude and bearing of the force that can balance the system. You see now they want the what? The bearing. So if I had to read, I have to redraw whatever that I was indicating there. So this and that. So remember here, I had the 128.08 Newton, and then this here was the 35.83 Newton. And then I had my resultant, which I had calculated now. So let's close off here. So my resultant was all the way like that. And then the bearing here, because they're saying I must get the bearing. So the bearing was 15.63. 15.63. Right. Now, the resultant, the FRS, what did I get? Calculating my FRS, I got 133 newtons. Right. If I get 133 newtons, that means this, if this is the F resultant, what they're asking us to calculate here, give the magnitude and bearing of the force that can balance the system. There is a term for this. The force that can balance the system is known as the equilibriant force. The equilibriant force. They're asking us to calculate the equilibriant force. But what are the facts that we know about the equilibriant force? We know that the equilibriant force is the same magnitude of force as the resultant force, but in opposite direction. So whenever we are looking for the equilibriant, the one thing that we have to note is that it will be the same magnitude of force as the resultant, but then only difference is that it would be acting in the complete opposite direction. So that means this would be our representation of the equilibriant force. So this will be the equilibriant. Now, what is the magnitude of that equilibriant? It has to be the same magnitude as the resultant. So this is supposed to be 133 newtons, right? But then now they want the angle in terms of the bearing. The bearing is always calculated from the true north, meaning from this y-axis here. So that means what we are looking for here is this angle here. So if we can just do like this, and then we are looking for the whole angle from here. So let me indicate the angle that we are looking for in terms of the bearing from the true north all the way to the force. So this is the angle that we are looking for. But how are we going to get that angle? If you can check here, allow me to just extend this line here. Allow me to just extend this line so that I can show you something. Okay, so now we have got the bearing there. And then the angle that the angle that is in question is all of this, right? So all of this here, this is supposed to be 180. But looking at this, we can see this is vertical opposite angles. So we must have 15.63 degrees as well here. Now the bearing here will be in what direction? So that means the bearing would have to be 180 plus that 15.63. And then we are going to get an angle of 195.63 degrees. That means our solution for 2.4, it's supposed to be what? The resultant is supposed to be, or the equilibriant force is supposed to be 132 Newton at a bearing of 195.63 degrees. And that's how you were supposed to have it. Awesome. So that's how you were supposed to tackle that question, all for a total mark of 13. So make sure that you go through this question here and make sure that you understand everything. But then with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.